Let's take a look at some sample problems from section 6-3, and we'll be working on page 267 in our textbook. In our first group, we're working on IQ scores, and it says find the area of the shaded region. The graphs depict IQ scores of adults, and those scores are normally distributed with a mean of 100 and a standard deviation of 15. And this comes from the Wechsler test. So we have a score of 91. So we need to calculate the z-score that goes with 91. Minus 100 divided by 15. So that's negative 9 divided by 15. And that's negative 0.6. Okay, so our z-score is negative 0.6. So we want to look up the z-score negative 0.60 in our table. Negative 0.60 is 0.2743. Remember that the table always shows the area to the left of the z-score. So we need the area to the right, so we need to take our 1 minus our 0.2743. So 1 minus 0.2743 is 0.7257. And number 8, we have an area shaded between two IQ scores, 112 and 124. So we need to calculate z for both of them. 124 minus 100 divided by 15 is going to be 24 divided by 15. And that gives us 1.6 or 1.60. And then 112 minus 100 divided by 15. I think that's going to be 0.8. Okay, so that means we need to look up the two z-scores and get the area for each one because we'll have to subtract them. So starting with the positive 1.60, 1.6 is 0.9452. And then for the 112, we get a 0.80, 0.7881. So we want to subtract the two. Point 9452 minus 0.7881. We get 0.1571. So that would be our area or our probability if we were talking about probabilities. Find the indicated IQ score and round to the nearest whole number. The graphs depict IQ scores of adults. Those scores are normally distributed with a mean of 100 and an standard deviation of 15. So in number 10, we have a positive IQ, positive X or a positive Z-score that's yielding an area of 0.1587 to the right of that z-score. So we need to figure out this area because that's what's in the table. So we need to subtract the area from 1. 1 minus 0.1587 is 0.8413. Oops, that's not my answer yet. I circled it, but I shouldn't have. Okay, so I want to get as close as I can to the area 0.8413, and what I found was 1.00. Now we need to find mu is 100 and sigma is 15. So to find x, we need 100 plus 1 times 15. So that's going to give us 115 for the IQ score. Okay, and number 12, our area to the left of our x is 0.9099. And we can see this is again a positive z-score that's going to go with that x. Okay, so 0.9099. Don't have to do any subtraction here. Alright, in the table I find the 0.9099 in the body. The z-score is 1.34. So our x is the mean plus 1.34 times our 15. And calculating that, we get 100 plus 1.34 is 15. I get 120.1, so that would round to 120. Okay, number 14 is using the same information. We're asked to draw the graph and then find the probability. Find the probability of 90 or greater than 70, which is the requirement for being a statistics textbook author. Okay, here's 100. Here's 70. So that's the area we're trying to find. So we need to change 70 into a z-score. We'll get negative 30 over 15, which is negative 2. Okay, so we want to look that up on our table, 0.0228 is the area to the left of the z-score. So we need to take 1 minus 0.0228 to find the area we need, which is to the right. 1 minus 0.0228 is 0.9772. Okay, so that takes care of that one. And let's turn the page to number 16. Find the probability that a randomly selected student has an IQ between 110 and 120. These are bright normal. So there's 100. And that's the area we're looking for. So again, we need to find two z-scores this time. These are our x. 120 minus 100 divided by 15. So we get 1.33. And then our other one is 110. So that's 10 divided by 15. 0.67, I think. Okay. So we need to look up these two figures in our positive table. Okay, so we have 1.33, 0.9082, 0.67, 0.7486. And to find the shaded region, we need to subtract these. And I'm getting 0.1596 as the probability. Okay, number 18, find the first quartile, which is the IQ score separating the bottom 25% from the top 75%. Okay, so we start with Z, and I want to use the negative table because I can see the Z-score will be negative. I want to look up the area 0.2500 and see how close I can get to that. 0.25. Right. Alright, I have 0.2514 and 0.2483. The one is off by 0.0014, the other is off by 0.0017. So the closer one is negative 0.67. So our x will be our mean minus 0.67 times our standard deviation. So it's going to be 100 minus 0.67 times 15. And I'm getting 89.95, which would be 90, round to a 90. Okay, and number 20, we have Mensa. Mensa International calls itself the International High IQ Society. It has more than 100,000 members. Mensa states that candidates for membership of Mensa must achieve a score at or above the 98th percentile on a standard test of intelligence. Find the 98th percentile for the population of Wechsler IQ scores. This is the lowest score meeting the requirement for Mensa membership. Okay, so higher than 98% of the general population. So it's going to be a positive. We're going to find Z first. We're looking for 9,800. Okay, 0.9798, 0.9803. The 0.9798 is a little bit closer, so that's 2.05. So our x will be 100 plus 2.05 times 15. 100 plus 2.05 times 15, which is 130.75, which would round to 131. So, in number 22, the U.S. Air Force requires that pilots have heights between 64 and 77 inches. Okay, and heights of men are normally distributed with a mean of 69.5. And sigma is